Hello, and welcome to this presentation on the Internet and how the Internet has affected globalization and trade since its inception from arguably the 60s to 1989 and today. We will be going over things such as CERN, Alan Turing, computers, how the Internet works, and then I will go into how it affects globalization and trade, or focus mainly on how it affects trade in e-commerce. So what is it? Well, the Internet is a global connection of computers, databases, and mainframes. It's all of these different technologies and, information hubs put together. It allows people to have all of the power of multiple databases and multiple programs, multiple mainframes with information. It allows them to weave it all together and have an interconnected system. So basically, they have multiple computers that are weaved together, and that forms a network. So you have a network of computers, and the internet is basically an interconnected network of networks, I guess you could say. So basically, they get all these networks and they put them together to form a giant network that encompasses the globe. And what does it do? Well, it allows for people to rapidly share and find information at a rate in which we have never been able to do before. It enhances communication ability, so people are able to communicate almost instantaneously. However, it doesn't require you to talk. So you can send a message and the message can be saved. And it also makes storing data easier. And what's important about that is while it makes storing data easier, it also allows data to be sent more efficiently as well. So, to go into a little bit more detail here, it allows people to rapidly share and find information. Now, before the internet was created, the only way you could really share information was to either hand deliver a file with all the information you want to share, or make a call and do it over voice. Unfortunately, by doing it over voice, you lose the ability to show just how much data you have or show how much stock you have and all that. It's not exactly up to time or up to date. It's more up to date than shipping a file or an envelope with all that data, but it's still difficult for somebody to grasp without having the ability to see it. And the point in which it makes storing data easier is previously you'd have to do everything by hand, and then you'd have to put it in file cabinets, which is still a very good idea. Make sure you do double bookkeeping and stuff like that. That way you don't accidentally double entry or make a mistake by doing double entry or problems like that. And you can now upload your data straight to the cloud and to the internet, and you can send that data straight from there. So you have a backup on the cloud, and you can also make sure that your information is properly sent to people on time. Now, to understand more about the internet, first you have to understand what the internet is comprised of. And the main aspect and the main component of the internet, well, they're computers. Of course, we know of computers because we all use computers, everybody does. However, a lot of people don't know exactly what they are or how they work. They just know that they can access the internet and they have a lot of very useful parts of our life. And we're going to talk about Mauchly and Eckert. We're going to talk about Alan Turing, and then we're going to talk about others. So, I'll play this short video very quickly.
Legendary names, legendary inventions. But who invented one of the most significant inventions of all time, the computer? Many embarked on the quest to invent such a machine, but who was first? And what machine qualifies as the first real computer? In 1834, British mathematician Charles Babbage conceived of the analytical engine, a machine with a memory and calculating unit which could be programmed. The analytical engine was never built, but would it have worked? In 1991, a difference engine based on a simpler Babbage design was built. It operates exactly as Babbage predicted, 150 years earlier. Can mathematical statements be proved true or false? This question became the foundation of theoretical computer science. Alan Turing, a British mathematician and cryptanalyst, imagined a machine that could compute any problem that was presented in a set of instructions. In essence, a general-purpose computer. The Universal Turing Machine was a conceptual blueprint for automatic computation. Meanwhile, German engineer Konrad Zuse built a series of machines for his calculations. Zuse's Z3 was the earliest fully functioning program-controlled machine. But war isolated Zuse, and his work wasn't widely known. Technology advances in World War II catapulted computing into a new modern era. American physicist John Mauchly and engineer Presper Eckert built the ENIAC, the first all-electronic computer controlled by a program. It was much faster than previous machines, but had no memory to store programs, and needed to be tediously rewired for each problem. After the war, ENIAC was declassified and unveiled to members of the scientific community. Now they saw the importance of storing the program in memory. They rushed to build their own computers. The Manchester Baby was a prototype of just such a stored program computer. Built by Manchester University, it ran a program from memory on June 21, 1948. A patent for the computer has never been awarded. Konrad Zuse tried in the 1940s, but his first patent application was denied for being vague, and his second was delayed for decades. In 1964, a patent on the ENIAC was awarded to its inventors, Eckert and Mauchly. The Eckert-Mauchly Computer Corporation had been acquired in 1950 by the company that became Sperry Rand. Sperry Rand now demanded royalties from anyone building a computer. When competitor Honeywell refused, a fierce legal battle ensued. But Honeywell's lawyers uncovered a little-known fact. In 1940, John Vincent Atanasoff, an assistant professor at Iowa State, had shown his computing machine to a visitor, John Mauchly. Because of that visit, the court's opinion was that Mauchly and Eckert derived their idea from a prior work. The general concept of the computer was not patentable. So, who invented computers? Not one person, but many, influenced and inspired by each other. Not a single breakthrough, but a series of incremental steps that continues even today.
So with that, I wanted to make sure that people had a basic knowledge of what a computer is and how it came about. That way, when it's explained about how packets are transferred between computers to other computers, and how it's then put into the network of computers and how that network forms the internet, it makes a little more sense. So with this next one, I'm going to go over a very quick beginning of the actual internet. So I'll jump in a couple seconds.
Or continents away. It didn't know how to get the message there, but it sent it anyway. The message probably took about half a second to arrive and told YouTube's computers to search for a file. A set of ones and zeros practically indistinguishable from the billions all around it, and to send that file back to you. YouTube's computers then sent the file back to your computer piece by piece, where those ones and zeros were interpreted as the start of this video. And the ones and zeros are still streaming in, even while you're watching me talk. It's pretty amazing when you think about it. And if you're curious how we ended up in a world where billions of...
And I just want to let people know, in case you were unaware, those ones and zeros are called binary code. Oh no. My apologies, I accidentally bumped that around. Sorry, I've been having trouble with this quite often.
Arrive and told YouTube's computers to search for a file. A set of ones and zeros practically indistinguishable from the billions all around it, and to send that file back to you. YouTube's computers then sent the file back to your computer piece by piece, where those ones and zeros were interpreted as the start of this video. And the ones and zeros are still streaming in, even while you're watching me talk. It's pretty amazing when you think about it. And if you're curious how we ended up in a world where billions of computers are all interconnected through this strange structure that we call the internet, then you're in the right place. Because this is the start of a mini-series of videos about the history of the internet. From some of the first attempts at making computers work together, all the way through modern social networks and on-the-go video conferences. Developing the right combination of software, hardware, technology, and marketing took decades, so we won't be able to talk about every important engineer or invention. But we hope you'll join us as we investigate some of the crucial ideas and events along the way. People started making computers work together pretty early on. As far back as World War II, when computers were big, clunky machines that didn't do much more than solve really difficult math problems. Even with the best computers of the day, it could take months to solve just one of the complicated physics problems involved in making the atomic bomb. But a team led by physicist Richard Feynman found a way of solving a bunch of problems at once. When computers weren't being used for part of one problem, they had those computers work on a part of a different problem. So one problem might still take a month, but they could also solve 3 or 4 in the same amount of time. And for really important calculations, they used their system to simultaneously do the same problem a whole bunch of times. That way, they were sure of the final answer, even if a couple computers made a mistake along the way. Another early step came in the 1950s and 60s, when colleges started separating their computer terminals, where someone would type their program from the computers themselves. This made it easy for a lot of different people to experiment with the new machines, while keeping the circuits and tubes safely away from tinkering hands. It was almost like an early form of today's cloud computing, where a user-friendly computer sends complicated tasks to a better, less accessible computer somewhere else. Except that today's cloud uses the internet, and in 1960, there was no internet. But people were starting to think about it. The US Department of Defense had recently created the Advanced Research Projects Agency, also known as ARPA, to keep its technology a step ahead of the Soviets. And a computer enthusiast named Joseph Licklider helped convince ARPA to fund research into a computer.
And Joseph Licklider is a very important person in terms of setting up the initial internet in the United States. I'm sure that Dr. DeGregory can explain more about it, but Joseph Licklider was important in helping smaller colleges and universities set it up on a small scale before it would be rolled out to countries and continents and states and stuff like that. So early on, he is an important person to talk about, and this video will go into more detail about him. Sorry, I made that mistake again. One quick moment to get back to my spot. but basically, he was important in getting the initial ideas of what the internet would operate as, because he helped set up the schools.
Into a computer network connecting scientists and engineers throughout the country. A few key colleges agreed to be involved, and ARPA started building the network in 1969. They called it ARPANET. It started fairly small, as a sort of messaging service between computers at UCLA, UC Santa Barbara, Stanford University, and the University of Utah. But it was the first network of its kind. And as ARPANET grew over the next couple of decades, its engineers would add features and solve problems that still shape everything we do online. One of ARPANET's first big innovations was what's known as packet switching. You know how sometimes in old movies, when someone wants to phone a friend, they have to call a switchboard operator first? The operator was there because those phones worked by what's called circuit switching, where signals could only get from one place to another if there was a single uninterrupted circuit between them. So the operator's job was literally to plug the wire from one phone into the wire from another. Circuit switching works great if two places stay connected for a long time, like they might if you're making a phone call, which is why most phones still work through circuit switching, except that now the circuits move automatically instead of manually. But it would be totally impractical for the internet to work that way. Your computer would only be able to connect to one other computer at a time, and it would take extra time whenever you tried to connect somewhere else. Today, some websites might connect you to 10 different computers from around the world at the same time, all of them needing to respond immediately if you click, all the while connecting and monitoring hundreds or thousands of other visitors all at once. So circuits all over the place would constantly be flipping around, connecting somewhere for a split second before switching away and connecting somewhere else. It just wouldn't work. Even back in the 1960s, engineers knew that computers send messages far too quickly to make circuit switching practical. So instead, they invented an alternative, packet switching, where different computers send messages along.
And my next video will go into a little more detail about packet switching and the like, because I like this one better. I feel like it's easier for people to understand, and I preferred that last video to help get a foundation of, you know, where computers started and how the internet started in the US. This one will go into more detail about Europe, France, and CERN. So let me introduce you to this one.
So, have you ever wondered who actually invented the internet? Some people have become zillionaires thanks to the internet, but all they did was invent clever ways of using the internet. So the person who invented the internet should be a gazillionaire equivalent to, say, God, shouldn't they? Who should get the credit then? Was it a British geek in a Swiss underground lab? Maybe. Clever Americans threatened with nuclear annihilation by the Russians? Nice idea. French scientists who decided to call their computer network the L'Internet. Interesting. Or was it thanks to a myriad of smart scientists working on something they knew was useful but didn't realize would be so big? Well, let's try and get some facts straight. There's the internet, a whole bunch of computer networks connected to each other, and then there's the World Wide Web, a way of making it easier to share information using all those interconnected computers. The internet as we know it today was at least 40 years in the making. One popular but wrong story is that the internet was developed by the USA so they had a communication network that would survive a nuclear war. According to one of the founders of the first network, the ARPANET in the 1960s, this first network experiment wasn't about communication at all, it was about optimizing processor usage, or time sharing, which basically meant that scientists could share computer power too. That was because until the 1960s, there was basically no network. You had big machines called mainframes, which sat in a room and processed computing tasks one at a time. With time sharing, these behemoths could process several tasks at a time, which meant their power could be used by several scientists at once. And obviously, once you start connecting computers together, you start to wonder about what you need to do to make communications between them easier. Scientists around the world were trying to solve this problem. So let's look at some of the other key concepts that were developed elsewhere. Starting with packet switching. In Britain, there was a commercial network developed by the National Physical Laboratory, but which never really got off the ground because it didn't get funding. But they did come up with the idea of packet switching, a way of avoiding congestion in busy networks by cutting up data at one end and putting it back together at the other. The French also played a role. They were working on a scientific network called Cyclades, but they didn't have a big budget, so they decided to work on direct connections between computers as opposed to working with gateway computers. Now, as an aside here, this admittedly isn't very scientific, but according to one theory, a spin-off of their research was the word Internet. But you don't have to believe it if you don't want to. So now it's the early 1970s. There's quite a lot of computer infrastructure, but communication is awkward and patchy because different networks can't talk to each other. TCP/IP solves this problem. The TCP/IP protocols form the basic communication language of the Internet, which labels the packets of data and makes sure that even though some pieces of the same data take a different route, they all arrive at their destination and can be reassembled. Networks really began communicating with each other in 1975. So you could argue that was the beginning of the Internet. Email was also very important. It was developed for ARPANET in 1972. Most Internet traffic in 1976 was email, because academics thought electronic post-it notes were dead cool. With networks that could talk to each other, communication was becoming easier. But all this communication was just text-based, and it was pretty ugly to look at. In the 1980s, a Brit called Timothy Berners-Lee spent time with CERN, the European Organization for Nuclear Research, where physicists are trying to work out what the universe is made of. He wanted to manage the scientists' information and make it possible for them to share and interconnect their work easily, making progress more likely. He did so by inventing an interface using HTTP, HTML, and URLs that made internet browsers possible. He called his browser the World Wide Web. So he didn't invent the internet, but he did invent the web. The first ever website which he created was at CERN in France in August 1991. So, once the initial infrastructure was in place, the key technologies had been invented, internet message boards exploded in the 1980s, the phone companies saw the commercial potential of digital communication, web browsers spread like wildfire in the early 1990s, and ordinary people discovered email, then the internet expanded rapidly and steadily and became workable for the masses from about 1995. Hold on, didn't US Vice President Al Gore invent the internet? No. And if you read what he said exactly, you'd know he never claimed to have done. But many people credit him with energetically pushing legislation that encouraged the spread of the internet. The internet exists because we need to communicate, and most of us like doing it. That's why humans have become the dominant species on Earth. You could argue that the internet is a natural evolutionary step and a manifestation of that need. It wasn't invented by anyone in particular, but when the building blocks were put together by all those cool scientists from all over the place, the internet became a communication tool, a retail tool, a research tool, a propaganda tool, a spying tool, a shopping tool, a dating tool, an entertainment tool, and a way of skiving off work while making it look like you're working or studying, which is what you may be doing now. Ultimately, though, you're communicating, especially if you leave a comment, and that might make you a better human being.
Alright, so now that we've gone over the internet, who invented it, how the World Wide Web came about, and what computers are and how they were invented, now I'm going to take a step forward and talk about Tim Berners-Lee. So Tim Berners-Lee was credited with creating the internet, really the World Wide Web, in 1989 with CERN, at the European Particle Physics Laboratory. And basically his work that he did was to make sure that people could easily communicate with others. And he's very much responsible for the universal computer languages that allow computers to communicate, such as URL, HTTP, HTML. They were all refined as, the use of web technology began to spread. And Tim Berners-Lee is, honestly, he should be seen as the founding father of the World Wide Web and basically of the internet as we know it today. Because his work is what got the whole interconnectivity to the point where it is now. As it was mentioned in the videos, the previous interconnectivity of computers and networks basically was only small range, small scale, and very much in-house sort of deal. You couldn't really communicate from Stanford University with Oxford University over in the United Kingdom. It wasn't a thing at that time. Now, the World Wide Net. Basically, this entire interconnected system of networks and computers, how it affects globalization and trade is that it makes global trade very easy. You see, now that you can instantaneously communicate with other people, other companies, other businesses, you have easy access to a variety of producers. So whereas before, you could only find a producer for, let's say, cobalt in, Utah, now you can find a producer of cobalt in, a poor example, but in Africa, in West Africa. And you can get it at a far cheaper price, which allows you to sell your goods or your products for cheaper, or it allows you to buy goods and products cheaper. That way you can provide your service for cheaper, which is basically how that affects the producer side of globalization and trade, as well as the retail side. Because you also can instantaneously find, a different producer for something, people can also find a different retailer for something. So you're always trying to look for an edge. For a consumer, that's very good because being able to find the best product for the cheapest price it's just seen as efficient. And because of that, people are always going to be inclined to try to find the best product at the cheapest price. And this easy access for consumers is what helps push and drive trade. It allows e-commerce to grow, and it's revolutionary in terms of global trade and global economics. Amazon Marketplace, eBay, these are examples of retailers that are retailers of retailers. If you think of your favorite brand, your favorite clothing, your favorite item, even from a specific brand, I guarantee that you'll be able to find them on Amazon and eBay. And on Amazon, it's often sold by the original retailer or the original brand. So then you have all the different brands and retailers competing with one another on this online marketplace. Very good for worldwide trade. Now, to go into more details about trade, business-to-business e-commerce is estimated to be about 90% of the global US $16.5 trillion e-commerce market. So really, this just means that most of the e-commerce in the US or in the e-commerce market is between business to business. So, somebody buying goods so that way they can put it in their shop, or maybe a retail store buying wholesale, that way they can sell, and the business is done online rather than in person, or rather than anything like that, going to the bank. It's just all done online. And this is important for the supply chain aspect, because supply chains wouldn't be able to function as well without the ability to move data globally, especially at the rate in which it moves. Now, to give an example, I provided this excerpt from a U.S. International Trade Committee, I believe. And basically, a company collects data from globally situated turbines and analyzes it in Denmark to understand the impact of temperatures, air speeds, and air pressure on turbine performance. The data is then used to identify when parts need replacing, and this lets the Denmark company alert warehouses which may be located in Asia or somewhere to deliver parts to a turbine in Australia before problems arise. Basically, with the speed and precision that the internet offers, trade and the ability to analyze your information, it allows you to be far more efficient, and that efficiency inevitably cuts costs and saves money. It saves money, it saves time, it saves resources. It's overall great for trade. These real-time alerts really do make the supply chain more efficient. And when countries start becoming more efficient, they can more efficiently specialize in the production of a good than they were ever able to do before, due to this instantaneous community that comes with interconnectivity. Countries previously could specialize in something, but they wouldn't know just how well they specialized in it in real time. They could only tell you what was done in previous, fiscal periods or previous shipments and the like. Now, because companies can see a precise estimate of their goods at pretty much a moment's notice, and they can send that information anywhere within minutes, countries are able to properly specialize, businesses are able to properly specialize, and it allows for a greater production of goods at unheard of efficiencies. I also want to point out that I pulled the Congressional Research Service numbers because I think it's really fascinating to understand how much e-commerce is a part of our day-to-day lives. Now, I'm sure everybody is very aware of that because they've heard of eBay, Amazon, Alibaba, and all of this. So I feel like I don't need to go into too much detail about this, but I do want to point out these numbers. For example, the McKinsey Global Institute estimates that e-commerce accounts for 12% of global trade of physical goods, both business to business and business to consumer. They also said that the U.S. International Trade Commission reports global e-commerce totaled over $27 trillion in 2016, with business to business comprising of over 85% of that total. It makes sense that a well-developed nation such as the U.S. would do a lot of e-commerce because it's at the reach of your fingertips. But don't let these numbers make it seem like developing nations aren't using e-commerce to make use of their goods. In fact, other studies show that 1.8 billion people globally purchased goods online in 2018. That's about a fourth of the total population of the world. 57% of online buyers purchase from foreign sellers. I would assume that that's because we are able to specialize more efficiently now than ever before. Now we can have a country that does a lot of production overseas somewhere for, let's say, batteries and such. Because in order to build something, you have to have parts shipped from various regions. Very rarely are all the components for something built in-house. For example, we can use Harley-Davidson. Harley-Davidson, up until recently, were technically American-built cars, or motorcycles. However, they did a lot of their manufacturing for motors and such down in Mexico. So essentially, they would manufacture that stuff in Mexico and it would come to the U.S. and be built there. It would use Mexican parts to build this American-made vehicle. And that, I assume, would be a large part of that 57% purchase from foreign sellers. And then I have some of my references here. And if there are any questions, I would be happy to go into more detail about them. Hey Jared, I just want to ask, can you tell me more about, specialization and the effects of globalization on that? Alright, thank you for asking. Now, how does specialization affect globalization? We have talked about the pin house factory. I believe that's what it was. I believe it was it Adam Smith who talked about it? Basically, specialization affects globalization because, unfortunately, it allows for this greater divide of wealth and inequality than we have seen in a very long time. Because it allows people to take advantage of these lower costs, lower prices, and it allows those people who are taking advantage of it to become very rich and very powerful in ways that have never been seen in previous human history. And this could potentially be a problem, as one of the popular things to discuss in politics right now is a universal basic income. And what makes that important or relevant is that this globalization and specialization will eventually lead to, people using the internet to program robots in their factories, in their manufacturing districts and regions, and that will take away more of the jobs from workers. And it is specialization, and it is the most efficient means of business. But as Dr. DeGregory says, sometimes our problems are caused by our greatest successes. And by these breakthrough innovations in efficiency, we are creating new problems for ourselves in inequality. Thank you very much for listening to my presentation, and I hope you have a wonderful day. Bye.